Greeting and wishes to everyone. Today I am going to deliver a video lecture on thin cylindrical shell which is subject to a internal fluid pressure small p is equal to 2 Newton per square millimeter and of diameter 150 mm and the length of the cylindrical shell is 3 meter and the safe or the working allowable stress in the material should not exceed 100 Newton per square millimeter. So here you have to find the thickness of the shell and also the hoop stress and the longitudinal stress. Thickness small t is equal to what? Then hoop stress F1 is equal to what? And F2 longitudinal stress is equal to what? So you know that the thin cylindrical shell is subject to the hoop stress and longitudinal stress. So therefore, the hoop stress F1 is equal to PD by 2T and the longitudinal stress F2 is equal to PD by 4T. So that is equal to F1 by 2. So here the thickness is not given, but the factor of the allowable stress in the shell material should not exceed 100 MPa. It is 100 Newton per square millimeter. So that is given. So therefore, the thickness T is greater than or equal to PD by 2F. So that is the worst stress. That is the hoop stress is the worst stress in the case of thin cylindrical shell because it is having PD by 2T, but the longitudinal stress is PD by 4T, half of that hoop stress. So therefore, thickness is greater than or equal to PD by 2F, that is equal to 2 into 150 divided by 2 into 100. So if we are working out, we will get the thickness of 1.5 mm. So I am providing the thickness should be greater than 1.5 mm. So that is 2 mm I am providing. The thickness of the thin cylindrical shell is 2 mm only. At any case, should not be less than 1.5 mm. So for the safer side, I am using 2 mm is the thickness of the cylindrical shell. So therefore, the hoop stress F1 is equal to PD by 2T. So it is equal to 2 into 150 divided by 2 into 2. So if you are working out, you will get the hoop stress as 75 Newton per square millimeter or 75 MPa. Then how to find the longitudinal stress? The longitudinal stress F2 is equal to half of F1, that is equal to PD by 40. If you are substituting it, you will get 2 into 150 divided by 4 into 2. So you are getting 37.5 Newton per square millimeter. So the hoop stress and the longitudinal stress, which are all within the permissible limit of the working stress or the allowable stress in the material of the cylindrical shell. At any case, these two values F and F2 should not greater than 100 MPa or 100 Newton per square millimeter. So this has been achieved. So the longitudinal stress and the hoop stress has determined thickness is 2 mm and F1 is 75 Newton per square millimeter or MPa, and F2, that is longitudinal stress, is equal to 37.5 Newton per square millimeter or MPa. You know that 1 MPa is equal to 1 Newton per square millimeter. So anyway, the problem has been worked out, and you can see that the problem the previous one, if you see the mirror image, you will get the correct value. Here also you can see, right, the thin cylindrical shell. What I have given the explanation for this, you can see. Thank you very much for the patient listening. Today we have seen about the thin cylindrical shell, hoop stress, and the longitudinal stress. Hoop stress is also called as the circumferential stress, and we have given the unknown factor of thickness can be determined by using the equation PD by 2F. That is, thickness should not be less than, that is greater than or equal to PD by 2F. So once the working or the allowable stress is given, you can work out the thickness of the shell. Thank you very much for patient listening. God bless. வாழ்க வையகம் வாழ்க வளமுடன்.